Okay, we are going to do 1.1 part 3. Remember, this is still the first section of your book, just separated into 3 parts. So we are estimating what we call irrational numbers. Ir is our prefix, basically meaning not rational, right? So rational numbers are numbers that can be written as a fraction, a over b, that's what we talked about. And their decimals will either terminate, end, or repeat, right? Put the line over it. So that's what we did in part 1 and part 2. But in part 3, we're talking about what's called irrational. So irrational numbers are numbers that are not rational, meaning they cannot be written as a fraction, a over b, and their decimals will not terminate or repeat. They will go on forever and ever and ever and ever and ever. Think of a number that does that already. What is a number we know that goes on forever and ever and ever and does not have a pattern? We cannot draw the line. Think about it. We'll talk about it in class. So our versions are basically square roots or cube roots that are not on that list we made in our last notes. So our last notes, part 2, we have perfect squares, numbers that came out as integers, and perfect cubes, numbers that came out as integers. We need that lesson, that part, to understand how to then estimate these square roots and cube roots that are not perfect, that do not have a decimal. We have to estimate them because they don't stop, and we can't figure out what they actually are, okay? So what we're going to do is we're going to use our list from part 2 to help us with these. So what we do first is we look at our list and we look at what 2 perfect roots are smaller and larger than the square root of 11. So if you look at your list from part 2, you'll see that the square root of 9, which is perfect, 3, and the square root of 16, which is 4. They are going to be consecutive like that, one after the other. Remember, that's what consecutive means, one right after the other. So you won't get like 3 and 5. You will not get like 2 and 8. They'll be perfectly consecutive, 3 and then 4, or 2 and then 3. So what this tells us is the square root of square root of 11 is somewhere in between the square root of 9 and the square root of 16. That means the decimal form of the square root of 11 is somewhere in between 3 and 4. So it's bigger than 3 but less than 4. This number will always be your whole number, the first one. So that means it's going to be 3 point something, and this is where our estimating comes in. Okay, so this is how we estimate. I'm going to find out how far apart 9 is from 11. It's 2 away. And I find out how far 11 is from 16. It's 4 away. So it's closer to 9 than it is 16, right? It's 2 away from 9 and 4 away from 16, so it's closer to 9. So that means it's closer to 3. So that means our decimal needs to be closer to 3. It's going to be a small decimal, like 2.1, 3.1, 3.2, 3.3, maybe 3.4. If it was, right, so it's got to be closer. So what we're going to do is down here, in your check to the nearest tenth, we actually have to check. So let's pick one. Let's do 3.2. So we're going to actually square 3.2, because remember, that's what we're looking for. What number did we square to get 11, right? Because 3 squared is 9 and 4 squared is 16. So what number did I square to get 11? Now remember, we're just estimating, right? Here I go, multiplying. So we may not get exactly 11. And then remember 1, 2, so I'm going to go 1, 2. So we got 10.24. That's actually pretty close. But I need to see how close I can get. So let's do 3 and 3 tenths. So this is 9 and 9. This is going to be easy multiplication, right? Oh, I got even closer. So technically we should check 3.4. So you can see why estimating initially is really important, because I don't have to check 18 times, right? So this is 12, 13, 12, 9, 10. Okay, so we got a little bigger. So now we know it's either 3.3 or 3.4. We want which one's closer to 11. So which one, 11 and 5600ths, or 10 and 9800ths, is actually closer to 11? We always want which one's closer, not which one's bigger, not which one's smaller, which one is actually closer. So 10 and 9800ths is closer to 11. So then our estimate, and since I'm estimating, I'm going to put an estimation sign, is 3 and 3/10. And that's it. We estimated it. We don't know exactly. It's 3 and 3/10 something, but I don't know exactly what it is. But that's as close as I can get. Okay, let's do the next one. So there's a negative on the outside, so it just means whatever I get for this square root, I'm going to put the negative on afterwards. I want the opposite of the square root of 42. So again, if we look at our list, one smaller of square root of 42 would be 36, right? That's 6. And then the one bigger is 49. That's 7. Remember, this one's always my whole number. So that means it's approximately 6 point something. So now let's find our differences. From 36 to 42 is 6. And from 42 to 49 is 7. So they're almost directly in the middle. It is a little closer to 6 than it is 7, but they're almost halfway. Right? So see how they're basically almost the same distance? So maybe we want to try 6.5. So let's check 6.5. So 25. 32, 30, all of this should be written down. Do not hesitate, do not do this just because I'm doing it. You need to also be writing this down because you're going to have to do this. So 36, so 39. So 5, 2, 12, 4. Look how close we got. 42 and 2500. That is so close. Okay, so technically we should check 6 and 4/10 just to see if it's closer, but we did a really good job estimating because that means we're really close. So 16, 24, 25, 24, 36, 7, 8, 6, 9, 10, 4. Way off. So look at, we're good, we're done. We landed to check 2 this time. So it's approximately 6.5. Remember, it is a negative, so I'm going to put the negative back on. So let's just go negative 6.5 like this. Okay, so this would probably be a good time for you to pause, but maybe pause in steps. So first, pause, see if you can find the 2 perfect squares. Check. Okay, pause, see if you can find the difference. Check. Okay, so maybe pause this one in steps to see if you can do this on your own. Okay, so hopefully you paused. The 2 square roots would be 64 and 81. That's 8 and 9. Remember, whole number. Okay, so that means it's going to be approximately 8 and something. Pause. Find your differences. Okay, so here would be, what, 16? Alright, and this is only 1. So that means it is super close to being 9. It's not going to be 9, but it's so close to being 9, it basically is. So what decimal is so close to being 9, but not being 9? It would be 8 and 9/10. Pause, check this. Alright, so we should have gotten 81. 72 plus 8 would be 80. Move over. 72, 64, 5, 6, 7, 8, 9, 10, 11. Right? So 71. Check me on that. So 1, 2, 9, 7. Oh, so close. Now, we know that 9 times 9 is 81. That's 1 away. We aren't going to, this is we're never going to say 9, so let's just say approximately 8 and 9/10. It's not 9, right? So we're not going to say 9, okay? And this is technically closer still, right? This is less than 1 away, this is 1 away. And there we go, we're done. So when we go to do cube roots, which is your next note taker, you do the exact same process except with cubes. So we're going to go look at our other list, our cube root list from part 2, and use that. Okay? So the cube root that gets me super close to 9 would be the cube root of 8. That's 2. And the cube root of 27, which is 3. This is still our whole number. None of this changes. So it's approximately 2 something. It's 1 away here and 18 away here. That's a lot. All right? So that means it's super, super, super close to being 2. Super close. So, I mean, it's basically 2. So let's just estimate 2 and 1/10. So 1, 2, 2, 4, 1, 4, 4. Now here's the difference. That's only twice. That's a square root. We need a cube root. So we're going to take 4 and 41/100ths and times it by 2 and 1/10. That's 3 times. See? 1, 2, 3. Cube root. So 1, 4, 4, 2, 8, 8. Ooh, add these, don't multiply them. 1, 6, 12, 9, 3 over. Look at that, super, super close. A little above, but that's okay. So super, super close, we're done. Don't forget about the negative, so approximately negative 2 and 1/10. Okay, so let's do the cube root of 77. So we would have the cube root of 64, right? That's 4. Cube root of 125, which is 5. So you can see the cube roots jump a lot more, which can make it a little more difficult, but also could make it a little easier because you have clear differences, right? So 77 is 13 away from 64, and it's really far away from 125, right? 48. I wrote 64. This is 17, right? What did I say it was? 13? 13. I don't know why I wrote 64 there. So we know it's super close to 4. So we're going to estimate something very close to 4, something small. Now, I'm also going to be nice. I'm going to let you not check it with a calculator, but you can do your multiplication with a calculator. So when you check your, try to your decimals out, go ahead and do it with a calculator. This is going to take a while. So I'm going to let you use a calculator right now, but you have to still show your work. So I'll show you an example. So down here, I'm going to still write, let's check 4 and 2/10, right? I'm going to still write it, but then I'm just going to go into my calculator, right? 4 times 4 and 2/10 times 4 and 2/10, and write it here. So notice I didn't do all of it. And then I'm going to write it again, but I'm just going to put it in my calculator. Times 4 and 2/10. I'm going to get 74 and 88/100ths. So you can do that too, okay? Makes it a lot easier. So it's a little small, so we're going to now try 4 and 3/10. So same thing, I'm just going to put it in my calculator. This is 1849. I'm going to times it again. Remember, these are cubes, so I have to do it 3 times. And I get 79 and 507. So this one, the second one, is closer, so we would say approximately 4 3/10. All right. I'm actually even going to let us do this one in class together, this last one. Okay, so just for process, it takes a little bit. But, so things to remember, not dividing by 2 or 3. Okay, use part 2 notes. Okay, I do want you to try these independent practices though. They're a little smaller numbers, so that should make it a little bit easier than the what numbers we were dealing with. That's why I didn't want you to do that last cube root, but I do want you to try, okay? So I want to see the perfect squares. I want to see what you're estimating. I need you to try. If you do not try, you will not get credit. You have to at least try. Okay, you can leave the third cube root blank, but you have to try the independent practice. Okay, until next time.